All right, this is the second video of section 7.4. We're going to look at those geometric mean shortcuts now that we've seen how to split apart the right triangle into three separate right triangles. So as a reminder, what we did in the first video and if you haven't checked out video number 1 yet, make sure you check out the part 1 video where we split apart the three right triangles. But our general scenario is we had a big giant right triangle and we dropped an altitude onto the hypotenuse of that big giant right triangle. And we saw that made three similar triangles, the big one in red, and then we had the small one, which in the last video we labeled green and yellow. So the big takeaway from this was that triangle 1, oh, there's the lag that always happens on Microsoft Word. Where'd it go? Triangle 1 was similar to triangle 2, which was similar to triangle 3. And we spent time setting up the proportions, which eventually led us to say, oh, look at that. There's some geometric mean shortcuts that actually happen every single time that we set up these three triangles. So what's nice is you don't actually have to draw the three triangles separately every time. There are three shortcuts that we're going to be using in the problems when we do these with numbers and variables. So the three possibilities you have when you're doing these problems, your geometric mean can show up in one of three spots. It's either going to be the altitude that we dropped, it's either going to be the left side or the left leg of the big giant right triangle, or it's going to be the right leg of the big giant right triangle. Those are our only three options for the geometric mean when we're doing these. So what that means, no pun intended, is that the GM, those three blue pieces, whenever you're not going to use all three of them in the same problem, but when you're setting the proportion up, the geometric mean has to go in the bottom left corner and the top right corner because that's where we put the means of a proportion. So three scenarios I'll show you. First scenario, let's say that the altitude that you drop onto the hypotenuse is your geometric mean. So I'm going to label that GM. That has to go in the bottom left corner, so that would be H. That piece is always going to be the geometric mean of the two little shadows that are right underneath it on the ground. So I'll highlight them in yellow and pink so you can see what I'm talking about. So H is the geometric mean of R and S. So my extremes are the two little chunks or the two little pieces making up that hypotenuse. That's if I make H my geometric mean. So again, I'm going to label this GM, GM. Now, second possibility, let's say that that big left leg is my geometric mean that I want to use in the problem. And it's really going to depend just on the scenario that they give you in terms of what's labeled. So if the left leg is my geometric mean, I'm going to label that B. So that's got to go in the bottom left corner and the top right corner. Then that is always going to be the geometric mean of the shadow on the ground right underneath it, which in this case would be R. So if I'm at this point right here in the bottom left corner, the shadow right underneath it would be R. And the distance all the way across from that bottom left corner to the bottom right corner. So the big giant hypotenuse of the original triangle, which you can think of that in two ways. That goes from R and includes S. So you could think of it as R plus S, or they labeled it C. So I'm just going to label that distance C. So in this case, geometric mean was the left side of the triangle, the left leg. So GM, GM. That is always going to be the geometric mean of the little shadow right underneath it and the entire hypotenuse. Third case, very similar to case number 2, is if we make the right leg the geometric mean. So in this case, that would be A. So now A has to go in the bottom left and top right. If I'm at the bottom here, my geometric mean A is going to be the geometric mean of the little shadow right underneath it on the ground, which would be S. So notice in the last problem, it was R because that was underneath B. Now it's S because that's what's underneath A. And it's the geometric mean of the shadow and the distance all the way across along that big hypotenuse, which, as I said in the last case, we could label R plus S, or we could just call it C. So those are my three possibilities for a geometric mean. It could be the altitude, it could be the left leg, or it could be the right leg. It's not going to ever be the two little pieces making up the big hypotenuse. It's always going to be one of these three pieces that I'm highlighting in yellow. Those are your only possibilities when you're setting up the proportion for the geometric mean. Now that's, I mean, I know it's kind of hard to remember. That's a lot of random pieces getting put together, but there is a little tool that I'm going to show you to help you, which we call Mean Mountain Man. So he is a skier, and I did link this digitally for you on Classroom, and I will print you a copy when I get back. But just to show you where it's at, hang on. We need, let's see, Google Classroom. There it is, Mean Mountain Man. If you go on Classroom for today, you'll see the Mean Mountain Man PDF. You can pull that up as I'm going through it. But this is what it looks like. So, scenario, here we go. We've got this guy named Mean Mountain Man, and he is a skier. And you'll notice the mountain is the big giant right triangle in this case, and there are three places where there are big snow mounds, which we are labeling GM for geometric mean, but in the context of snow and skiing, that stands for giant moguls. And if you've never skied before, a mogul is a big snow mound that you have to ski around. Okay? So giant moguls is our geometric mean analogy. So I have three possibilities for where my giant moguls can go. Can go on the left side of the mountain, the right side of the mountain, or the snow can lead you from the chairlift all the way to the top of the mountain. Those are my only three possibilities for the geometric mean. So I'm going to circle that in blue. Now, the Mean Mountain Man at any given time could either be at the bottom of the mountain or the top of the mountain. So I want to look at three scenarios for how you could set up these proportions with this analogy. In the first case, let's say that the left leg or the left side of the mountain is the geometric mean. That is where the giant moguls are at. So I'm going to do this part in blue. Mean Mountain Man's going to go down the left side of the mountain. Here he is, Mean Mountain Man. He skis. There's his skis. I'm not an artist. And he gets to the bottom of the mountain, and maybe he bumped his head on the way down. So he arrives at the first aid station. In your proportion, notice how that left side of the mountain is going to go in the bottom left corner and the top right corner, because that's the giant moguls. That's the geometric mean. Now, to figure out the two extremes in the top left corner and the bottom right corner, what distances do I want to use? Well, he's at the bottom. He gets checked out at the first aid station, and he has two decisions to make. He can either go back to chairlift and go up the mountain for more skiing. So that distance would be the first aid station to the chairlift. Or maybe he wants to go all the way across to the ski lodge for some hot chocolate. So that would be the distance from the first aid station to the ski lodge. So in either case, that would be where I put my two extremes. It would be either the distance from the first aid station to the chairlift, which you'll notice is the little shadow that we talked about before, and the distance all the way across that big giant hypotenuse. That distance all the way from the first aid station to the ski lodge would go in the top left corner and the bottom right corner. Now, case number two, let me erase the blue. We're going to have him ski down the right side of the mountain this time. Okay. So now, Mean Mountain Man decides he wants to try a different hill. So we'll do this one in red. So now he's going to go down the right side of the mountain this way. That's my geometric mean this time, so I'm going to circle that in red. So in the second proportion, GM, bottom left, top right corner would be the right side of the mountain, that distance. When he gets to the bottom, so here's Mean Mountain Man, he enjoyed skiing, didn't bump his head this time, so he decides, I'm going to enjoy a cup of hot chocolate at the ski lodge. And then he has two decisions to make. He could either go back to the chairlift, so that shadow underneath the snow mounds from the ski lodge to the chairlift, or maybe just to play it cautiously, he wants to get checked out and make sure he can go skiing again. He goes to the first aid station to have himself looked at. So he could go from the ski lodge all the way across, past the chairlift, all the way across that distance to the first aid station. So those would be my two extremes for that proportion if we use the right side of the mountain as the giant moguls, the geometric mean. And then the third case, I'll do this part in green. Maybe he's standing at the chairlift and needs to make a decision before he goes up the mountain. He could either go from the chairlift to the first aid station to make sure that he's ready to go for another round of skiing, or he could go to the other side on the right to the ski lodge and have a cup of hot chocolate. So he has two distances he could go. He could go from the chairlift to the first aid station, or he could go from the chairlift to the ski lodge. So the two little pieces making up that big ground distance, that big hypotenuse. That is going to be if you're using your height here, your altitude is your geometric mean. So that would be the snow that gets him from the bottom of the mountain to the top of the mountain. So if we make this snow mound, that chairlift, if we make that the geometric mean, that's going to be the geometric mean of the two pieces right underneath on the ground. Chairlift to the first aid or chairlift to the ski lodge. So those are the two that I'm mentioning right here. And that's if we use that altitude as our geometric mean. So it's a little analogy to help you. If you like it, use it. If you don't like it, you can memorize the formulas in any way that you'd like. And then your third option is if you don't want to use the shortcut, you can draw the three right triangles separately every time, and you can set up the proportions. You just have to be careful to make sure that you give them all the same orientation before you set up those triangles. But I think this is a silly little way to help. All right, that should do it for the second video. I'm going to wait on examples with numbers and variables until the third video, but this should help you with your homework assignment. Happy mathing.